Greetings. My name is Nauman Jana Frankideria, and today me and my team, which is Team 19, are going to present on our project regarding the automatic escalator system for Mechatronics team project. So this is the project overview, which consists of the introduction, literature review, methodology, result and discussion, and conclusion and recommendations. The escalator was invented by J.C.W. Renault in 1891 and was initially called the endless conveyor or elevator. The first commercial installations of the escalator was at the All-Iron Pier, Coney Island in New York in 1896. Since then, escalators have become a common mode of transportation in public places such as shopping mall, airport, and train stations. However, the reliable and safe operations of the escalator is critical for the passenger safety and operational efficiency. A programmable logic controller, which offer improved flexibility, dependability, and safety features, have recently gained popularity as a solution for managing the escalator. A programmable logic controller can be utilized to control escalator many electromechanical components, such as the motor, sensor, switches, and the indicator. The escalator can be computerized and operated more accurately by utilizing a PLC, which increases the efficiency and dependability, ensure safe and dependable operations, and lower the energy usage and maintenance costs. The purpose of this project is to design, develop, and operate a programmable logic controller based control system using a ladder diagram for an escalator that guarantees safe, dependable, and efficient operation while minimizing the downtime and maintenance costs. Several safety measures have been included, which is the emergency stop button and condition monitoring should be included in the system along with the ability to remote monitoring and diagnostic. The ultimate objective is to maximize the escalator overall performance and longevity while also giving the user a convenient and smooth experience.
Assalamualaikum and good day. My name is Fatiha and I take part in this project of literature review and research findings. Starting off with our research discovery, we started by constructing few of our research questions. Number one, we would like to know what does the existing research papers have already discovered with regards to control system of an escalator. Number two, we would like to know how does this control system mix up the PLC logic and its ladder diagram. And number three, we would like to know if there's any existing research gaps and further opportunity of research in this field. After extensive research, we stumbled upon 5 papers that we would like to highlight. The first paper mentioned about the framework of a safety system. The second paper mentioned about an energy consumption system. The paper number 3 mentioned about intelligent braking system. Paper number 4 proposed about a central monitoring system. And paper number 5 mentioned about the mechanical of an escalator system itself. All of these papers fulfill the requirement for research question number 1, but they are inadequate for research question number 2, which creates a huge research gap and opportunity for this project for us to configure our ladder diagram and PLC design.
We approached the project by first researching and reviewing literatures to gather information on the various working principles of an escalator. This includes the system's use, safety measures, and etc. Then, discussion is done for the selection of our escalator's process flow. We repeated these steps until it is ensured that the process is in good comparison with past researches. After that, we select the PLC, or in other terms, programmable logic controller, input devices, output devices, and logic control tasks to use in the ladder diagram as per our escalator design that has been discussed previously. After constructing the ladder diagram, we check that it works as per our escalator process flow design and repeat this process until the ladder diagram is complete. In our escalator system design, there are 5 main functional systems used. Firstly are radar sensors that detects movements of passengers into and out of the escalator. Second is indicator lights that provide important information to passengers on the status and operation of the escalator, which are the direction up and down, whether the escalator is moving or on the verge of stopping, to show if maintenance of escalator is due, and also indicator light near the skirt deflectors at the bottom side of the escalator, which acts as a safety measure. Other than that, the escalator has energy saving mode, where the escalator will stop when it is not in use by passengers. And for both these energy saving mode and due maintenance systems to work, timers are used. There will be motors placed to drive the motion of the stepping tracks, handrail, and skirt deflectors that has brushes attached to them. Lastly is the emergency stop button to immediately stop the escalator in the event of an emergency. First of all, before the escalator starts moving, there is already indicator light showing the direction for up and down. Then, when a person passes through the in sensor, motor will start running and causing the track, handrail, and skirt deflector to move, while also causing the indicator lights for ongoing escalator movement and skirt deflector to turn on. Then, once the person exits through the out sensor, timer of 50 seconds will start, and once reached that 50 seconds, escalator will stop moving and go on energy saving mode until the next person enters the escalator through the in sensor. This is to ensure that motor will run until all current passengers of the escalator have exited. Whenever the escalator moves, timer for due maintenance will turn on until it accumulates to 70 days, where indicator light for due maintenance will turn on. Emergency stop button is also present at both ends of the escalator to immediately stop all escalator systems in the event of an emergency. There are 5 types of ladder logic symbols used for our escalator system. There are normally open contact and normally closed contact for most of the escalator subsystems. There is also output used for indicator lights and escalator movements from the motor. And lastly, retentive timer used for due maintenance subsystem and on-delay timer is used for the energy saving mode. The difference between these two timers is in their behavior and application. Retentive timer continues to count time, even if the PLC program is interrupted. Therefore, it stores the accumulated time value in a memory location and continues to count the program is resumed. While on-delay timer starts counting time when a trigger condition is met. Then activate the output after that specified time delay.
Hello everyone, my name is Elia and let us continue with result and discussion. So before we can design our PLC ladder diagram, these are the few general assumptions that we make to set the parameter in the PLC. So the speed of the escalator is assumed to be 0.5 meter per second as per stated in guideline provided by Con Malaysia, which is the global leader for escalator and elevator industry in Malaysia. So the type of escalator is single escalator arrangement. This is for the sake of simplicity, and then for the sake of energy efficiency and minimum energy consumption, the total rotation before the escalator due to maintenance is assumed to be 30,000 rotation. So this total rotation will be translated into total time taken of escalator to operate before it's due to maintenance. So how do we know the time taken for escalator to complete one rotation? Is basically shown at the right side of the slide. This is a basic general math calculation that we have done, and we can get the total time taken to operate the escalator before it's due to maintenance is actually 1.5 million seconds, which translated into approximately 17 days of operation without stopping. Alright, so here is the final design of the PLC ladder diagram for the automatic escalator. So how this escalator works is it will only operate when there is passenger on the escalator, and then it will turn off when there is no passenger on the escalator. So the two types of timer that is used is the maintenance timer, and then the second one is the motor off timer, which is the on delay timer before the escalator stop. So the maintenance time is actually will turn on when the total operating time has reached, as per stated in the previous slide. And for safety feature, we have include emergency stop button in the design. And then the 3 scenario that is estimated for this design. The first one when there's 1 passenger at a time. The second scenario is when there is 2 or continuous passenger at a time. And then the third one when there is emergency situation.
So this is the first rung of the ladder diagram. The function of the first rung is to switch on the direction light of the escalator, which is an indicator light to show whether the escalator goes up or down. In this rung, we have the start switch as the normally closed contact and direction light as the output. The simulation of this rung is divided into 2 cases. The first one is when the start switch is off, the switch is closed and current flows into the direction light output. Hence, the direction light is activated. In the second case,
When the start switch is on, the switch is open and breaks the circuit. Hence, the direction light output is deactivated. Next, the second rung is the circuit for the motor, side track light, and moving light of the escalator. In this rung, we have 4 inputs which are in sensor, which is to detect a person entering the escalator, motor to move the escalator upwards or downwards, emergency stop button to stop the escalator quickly in risk of injury, and motor off to switch off the motor whenever needed. The in-sensor and motor are connected in a latching circuit as the normally open contact, then connected with emergency stop button and motor off, which are the normally closed contact. Also, the output are connected in parallel to implement the simultaneous output. The simulation of this rung is divided into 3 cases. The first one is when the in-sensor is switched on. The in-sensor is activated when it detects a person approaching the escalator, then current flows through the emergency stop button and motor off switch, and immediately activating the motor, side track light, and moving light. When the motor output is activated, the motor switch on the left-hand side will automatically switch on, as they have the same label. Current will continuously flow from the motor input and activate the outputs. While the current flows through the circuit, the retentive timer is used to count up the time to do maintenance on the escalator. For the second case, when the in-sensor is switched off, or in other words, when the sensor detects no person, the switch will open. However, the current is still flowing from the motor switch on the left-hand side and eventually keeps the output activated. Therefore, the escalator will still move upwards or downwards even when it detects no person through the in-sensor. For the third case, when the operator releases the emergency stop button, the switch will open and break the circuit. Hence, the output will be deactivated. Next, the third rung is correlated with the second rung, in which when the motor output in rung 2 is activated, the motor switch in the third rung is also activated. This rung is the circuit for another category of the escalator components, which are handrail, skirt deflector, and track. The simulation of this rung is divided into 2 simple cases. For the first one, when the motor switch is on, the current flows and activates the outputs. Meanwhile, for case 2, when the motor switch is off, the circuit will break and deactivate the outputs.
The fourth rung is where the signal from the maintenance time timer mentioned in the second rung will activate the maintenance light. As the time of maintenance time is set at preset value of 1.5 milliseconds as per stated in the calculation earlier, the maintenance light will turn on once the escalator has been running above the time mentioned. So the light up maintenance light will indicate the maintenance crew that the escalator is due for maintenance. It also worth mentioning that the escalator will still operate even if the maintenance light is activated, as it is not impacting the safety, but only reducing the efficiency of the escalator. However, if the accumulative value has not reached the preset value, the light will remain closed as the rung is not activated by maintenance time switch. So one of the uniqueness characteristic of this design is the on-delay function of the motor if there is no passenger on the escalator. In order to program the PLC to achieve this function, the fifth rung added where input from out sensor will trigger the output delay off. The timer of motor off timer will activate once the output response has reached the preset value. So the selection of on delay timer in the PLC fiddle allow the timer to reset the accumulative value to 0 if the out sensor triggers again below the preset value. So when there is passenger exiting the escalator, the second passenger will still have 25 seconds to exit the escalator without having the escalator turn off while the second passenger is still in the middle of the escalator. The sixth rung is the continuation of the fifth rung. This is where the motor off timer switch from the timer in fifth rung will trigger the output motor off. The normally open switch will be activated once motor off timer has elapsed, passing the 25-second preset value. Once motor off output is activated, the motor power will be cut off by the normally closed switch in the second rung. The motor, along with the other component, will be turned off, indicating no passenger on the escalator. This is the second case. When the motor off timer switch is off, you can see the normally closed motor off switch in the second rung will maintain closed and the motor is operating. It indicates there is still passenger on the escalator. So why this feature is important? Because it promotes energy saving. Alright, let's do some simulation of the PLC ladder diagram. So let's say there is a passenger entering the escalator, and then off, we can see the motor is running. And once the passenger is passing through the exit, right? So it will delay off by 10 seconds. You can see it's running, and once achieve 10 seconds, motor is off. Alright, so let's move to second scenario when there is two or continuous passenger. So in sensor, out in sensor activated, motor on, out sensor, but it's still on. And then let's say another passenger entering, you can see the motor off timer will be reset to 0 value. You can see here, and so the escalator will not stop operating, and only then when the out sensor is activated, it will delay by 10 seconds. So the value here, 10 seconds and 50 seconds, is shortened for the sake of simulation. So let's move to the third scenario. Even if the in sensor is activated, but once the emergency stop button is on, you can see the motor is off along with the other parameter. So this is the important safety feature that will make sure the safety of the passenger. Alright, so for the maintenance time timer, we use a rotative timer. So let's simulate it. Once the motor is on, you can see the maintenance time timer is start running, right? So let's say we on the out sensor and it reached 10 seconds. Let's wait for a little bit. Alright, so you can see motor is off and the timer here will stop running. This will indicate that the maintenance time will actually accumulate to the total operating time of the escalator. So we turn on again the motor, and when it reaches 25, the maintenance light is on. So the function can work well.
There are many benefits of our escalator to the society. It improves safety because unlike traditional stairs, escalators have no sharp edges or gaps that could cause people to trip and fall, especially when the escalator has safety features. Secondly, it improves mobility by providing efficient means of transporting large numbers of people up and down different levels of the building, especially at busy public spaces where large crowds need to move quickly and safely. Other than that, it also increases accessibility for people with mobility issues, such as elderly people, people with physical disabilities, and other people who may have difficulty in using stairs. Lastly, it is space-saving as escalators take up less space than traditional stairs and can transport more people in a given amount of time. It is new and practical to the society as buildings often save energy from escalators by switching the escalators on and off based on schedules, but this may impose difficulty to passengers, especially for people with mobility issues and during peak hours, where large crowds need to move quickly and safely. But our escalator only stops working when there are no passengers on the escalator. It also has new maintenance system based on timers, unlike common escalators. As a conclusion, our project are able to design, develop, operate a PLC using ladder diagram of an escalator. Taking few cases into account that we refer to, in case of one passenger, continuous passenger, due maintenance and energy saving mode, contrary, without energy saving mode, and by the end of the day, the full ladder diagram of a functional escalator. Achieving our first objective, we also achieve our second objective, which is to simulate the operation of an escalator system using any sort of simulation software. In this project, we use PLC Fiddle. Taking into account safety measures, economic consideration, efficient operation, inclusive of its downtime and maintenance.
The installations of a PLC-based escalator control system is an important step towards enhancing passenger safety, optimizing operating efficiency, and lowering maintenance costs. The system efficiency and capability can still be improved in several ways, and one of which is by using a machine learning algorithm to boost the fault detection and preventive maintenance. Even more downtime and maintenance expenses can be saved by using the machine learning to evaluate the sensors data and forecast when maintenance is necessary before an issue arises. In general, the installations of the control system for the escalator that is based on the PLC is a great place to begin, and there are few areas in which additional work may be done to further enhance the system functionality, safety, and efficiency. That's all. Thank you.